My name is Stropek. I'm coming from Austria, and there I have a small company, and generally I'm doing consulting. I'm helping teams all across Europe to get successful in offering software as a service solutions in the cloud. And I'm going to talk about Docker on the one hand side, and about a specific topic about Azure, the Azure Resource Manager. I need my screen. Yeah. Thank you for the introduction and welcome to my talk here, Docker Containers in the Microsoft Universe. Let me start with apologizing for my voice. Unfortunately, I caught a cold during last weekend, and so the voice that you currently hear is not my typical voice. I will do my very best so that you still can understand me. As it was said in the introduction video, my name is Stropek. I'm coming from beautiful Austria, and it's my first visit here in Vilnius, and I'm very glad to be here. I do a lot of work with the Microsoft stack. I'm an Azure MVP and regional director. And I've been using Azure and all technologies related to Azure for many, many years. And of course, containers is a very important topic. Let me quickly give you a summary of what I'm going to talk about in the next 35 minutes or so. That reminds me of starting my timer. The first question I want to ask or answer with this talk is why? Why do we need something like containers on the Windows platform if they are already great on the Linux platform? I'm going to show you which options you have, and there are a lot of options how you can use containers on the Windows platform, on the client, on the server, and things like that. And finally, I'm trying to skip lots of my slides. I have some slides here, but I'm going to focus on lots of demos, and hopefully internet will stay there because then we can see Windows containers in actions. Okay, let's start with an overview. Which options do you have and what can you do? The first thing, of course, Microsoft loves containers. Microsoft is not the Microsoft you maybe have known 5 years ago or something like this. I've been working with Microsoft for over 20 years now, and believe me, a lot of things have changed in the last few years. A lot of things have changed with Azure, and one of the things that has changed is Microsoft's love to open source, to Linux, and with that, to related technologies like containers. The first thing that you will see is that Microsoft contributes heavily to the Docker ecosystem. And one of the things that Microsoft did is they contributed to the Docker client. So what you can do now today is you can fire up a command prompt here and say Docker info, for instance. And if you take a look at it, I'm here remotely managing a Docker based on Alpine Linux. What I'm running here is Docker for Windows, not Docker on Windows. It's just a Linux VM. I could fire up the Hyper-V console and you will see a small Alpine Linux running on top of it, and I can use the Docker client here within my Windows command shell. But Microsoft did more. What they did is, maybe you have heard about that, they integrated canonical Ubuntu in certain Windows 10 SKUs. So if you are running Windows 10, you get a Linux, a native Linux, directly embedded into your Windows 10 machine. What's happening behind the scene? It's not Docker, it's a so-called Pico process, and it talks through a driver with a Windows NT kernel, and you are running a native Ubuntu on top of the Windows NT kernel. And here we can run the native Linux kernel, and what you see here is, what you can see here is, of course, I can also remotely manage inside of Windows 10 in a native bash shell with a native Docker client. I can my Linux containers. But the interesting thing comes now. What I can do if I'm running Docker for Windows, I can easily, if I'm running Windows 10, switch to Windows containers. And that's the first thing where you really see Docker on Windows in action. So I'm now switching gears. I'm now not using containers on Linux anymore inside a Hyper-V machine, but now I have really Windows containers on top of the Windows kernel. And to make things a little bit more interesting, I will stay here in my native bash shell. So I'm still on Ubuntu running natively on top of the Windows NT kernel. And if I now say docker info, you will see that now my Windows 10 is natively speaking the Docker protocol, and I'm using a bash shell to access a Windows 10 enterprise. If I say Docker images, you will see that on my local Windows 10 machine, I just have for demo purposes one ready-made image. It's a Nano Server, so it's a Windows server, and of course I can spin it up. So what I'm going to do is I'm going to say run an interactive container and throw it away when I'm done, and let's say Microsoft Nano Server and run a command shell. This will probably take a few seconds, but only a few seconds, and then I should have running a Windows Nano Server on top of my Windows 10 machine. Let's see, inside of my bash shell. I just switched it so it takes a few seconds until everything is warmed up, and now it is a little bit crazy, isn't it? I'm inside of my Windows 10 machine, I'm running native Ubuntu on top of the Windows NT kernel, running the native Docker CLI to access a Windows container on the Windows NT kernel. So this is what I'm doing here, and it really works nice. So what you can do is you can use your Windows 10 professional developer machines, install Docker for Windows, and install Docker on Windows, and then you have Linux containers and Windows containers, and you can manage it equally from your DOS command prompt, and you can manage it from your embedded bash shell. Okay. So this is that one. So why should anybody use the bash shell if you have a DOS command prompt? Those of you who are regularly using the bash shell, you know it. But the most important thing is if I, for instance, say Docker images, and I say Docker run interactive Microsoft, and if I press tab, I get this nice completion experience that I typically don't get on the Windows shell. So this is something that's very nice, and this is why I typically use the bash shell when interacting with containers, either on Linux and on Windows, on my Windows 10 developer machine. Okay. I've shown you that one, the Docker client and the Windows shell. I've shown you that one, and yeah, I've shown you that one. Okay, next thing. You've seen that one, and yeah, okay. Windows containers on Windows. It's a little bit difficult with all the different names. To make one thing clear, if I'm talking about Docker for Windows, I'm talking about Linux containers on Windows. If I'm talking about Docker on Windows, I'm talking about Windows containers on Windows. Microsoft contributes heavily to the Docker ecosystem, as I said, and what they have done is they have created lots of ready-made images. So if you run Docker on Windows or Docker for Windows, you can go to the Docker Hub. Let's navigate there. And let's try the following. Let's do a search for Microsoft. And what you will see is you will see lots of ready-made images inside of the Docker Hub. And of course you will see things like .NET. If you are a .NET developer like I am and you are running .NET Core, Microsoft provides you with ready-made images either for, you see it here, Debian, so that's Linux containers. And if you take a closer look, you will see down here, for instance, that they also provide Windows on Windows containers. So if you want to run your .NET Core application on a Windows server, and you want to run it in a containerized fashion, no problem. You can take the ready-made container from Microsoft and base your application on that one. But it's not only that. It's not only the .NET Core, which is by nature a cross-platform environment. You also have other things. For instance, if I scroll down a little bit, and if I'm, where is it? Let me quickly look again. Here it is, for instance. ASP.NET. Microsoft ASP.NET is not the .NET Core flavor. It's the good old .NET 3.5 and 4.5 version. And as I said in the beginning, I want to discuss why this is important. Many people ask me, hey, isn't Microsoft copying the Linux ecosystem and just introducing Docker on Windows doesn't make sense because it works so good on Linux? Why should I run it on Windows? Well, not all projects start on a clean slate. Not all projects are greenfield development. Sometimes you have to live with existing applications which might not be based on some cool stuff like .NET Core, like Node.js, like Python or things like that, but you have to cope with a rather old .NET 4.5 or 3.5 application, but still in a DevOps environment you want to benefit from containers. And therefore I think it's really important to know that you have Windows on Windows containers, and that Microsoft does not only give you the containers for the new technologies based on Linux, but also for the existing technologies which are well established and very robust, and which we all have been using for many years. And this is such a thing. If you're, for instance, a good example, in my opinion, is also, let me see if I find it quickly here. Uh, ba, 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 ba. Here it is. As you might know, Microsoft also provides now in a preview version the SQL Server running on top of Linux, also inside a ready-made container, but down here you see the SQL Server on Windows. So there is an official image, for instance, for running SQL Server in various flavors in the Standard Edition, in the Developer Edition, inside of a container. So what you can do is you can use, for instance, Windows containers inside of your continuous integration pipeline to do some integration tests and spin up a short-lived container based on Windows with your SQL Server inside of it. And until recently you had to do that with Windows. Now you have the choice. You can run your SQL Server inside of a Linux container or inside of a Windows container. It's really up to you. When we're talking about servers like IIS, ASP.NET, or SQL Server, and so on, of course, I want to run these servers not only on my Windows 10 boxes, as I've shown you a few moments ago, but I want to run it on real Windows servers. So let's switch gears and switch to container host that I've created for you before I went to this session. Here you see it. It's running, of course, in Azure, and here it is. It's just a regular Windows Server 2016 running in Azure with Docker installed. Docker is very simple to set up on a Windows server. You can do that automatically, and Microsoft offers ready-made images inside of Azure. So if you want to spin up your Windows Server 2016 with containers enabled, you just go to Azure, you say new VM, and there is a ready-made image that says Windows Server 2016 with container support. You just wait 5 minutes and you have your server, high availability server, running in Azure. And I did that before this session, and I copy the IP address. And to make things a little bit more interesting, again, I will go to my Ubuntu box here, and I will say export Docker host equals to TCP, copy the IP address, and enter the port. And if I now say Docker info, you will see that I'm now accessing a Windows Server 2016 Data Center Edition. So again, let me point out, I'm using the native Linux Docker client inside of Ubuntu Linux to speak the Docker protocol, which is compatible with Windows Server, and I'm now accessing a Windows Server, real Windows Server, where I can run production workload for IIS, for SQL Server, and so on. In the future, you will also be able to run Docker swarms on top of Windows Server if you want, for instance. And you can use the usual tools. All the tools that speak the Docker protocol, they can access a Windows server with containers just as a Linux server with containers, because under the hoods they are using exactly the same protocol, and this is what I wanted to show you here. So let's do the Docker images again. And here you see on that server I installed a bunch of images. I have the Nano Server, which is the base image for the smallest SKU that's currently available. Who has heard about Nano Server before? Let me ask you. Only a few hands going up. I think the Nano Server is really a very interesting SKU of Windows. It's brand new. It came with Windows Server 2016, and it has been optimized for the cloud. It has been optimized because it's the smallest SKU that you can get for Windows. It's really stripped down as far as it's currently possible on the Windows kernel. Of course, it's not an Alpine Linux, don't get me wrong, but it's a very, very much smaller Windows server than you used to have. The Nano Server, doesn't offer all the functionalities that you are used to from a full Windows server. So I encourage you to take a look at the Microsoft documentation. To get a deeper understanding of what the limitations of the Nano Server are. But the point here is you can really tweak the Nano Server to exactly your need. It doesn't come with all the services pre-installed and you cannot get rid of them. You can really install only those features that you are interested in. So Nano Server is a perfect operating system if you are running Windows on Windows containers, if you want to have the smallest possible containers in the Windows world. Let me make one thing very clear. This is not Alpine Linux. I mean, take a look at the size here. That's still a gig here. It's not an Alpine Linux, as I said, but compare it with the 10 gigs of the Windows Server core. If you're now thinking, well, let's switch to Nano Server with all our applications, I would do some testing before, because as I said, Nano Server doesn't support all the features, and if you want to use Nano Server containers with your applications installed in it, please make sure that your application runs natively on Nano Server before trying to put them into containers, because not all applications will run in it, and typically you will need to do some tweaking. Windows Server Core is the classical Windows Server Core that you probably all know and love or not. Here you have a ready-made container from Microsoft with IIS installed, so if you want to run some IIS-based workload, you can use that one. And of course you get the 4.5 .NET versions and you get the .NET Core versions, and we could go on and on with things like SQL Server, for instance. Okay. So now we were remotely managing our servers, and I already mentioned the ready-made containers here. Let me take a look. Yeah, this one is interesting. If you want to see this one in action, you should come to my next session about Azure Resource Manager, because what Microsoft now does, they are creating Docker images for all their tools. So for instance, if you want to run the Azure CLI, the command line interface for Azure, you don't have to install the prerequisites and the CLI anymore. You just spin up a Docker container and it's immediately up and running. And that's the important thing here. So this is, by the way, a Linux-based image. So Microsoft offers Linux and Windows-based images depending on the situation and the prerequisites of the software. Visual Studio now also got lots of support for Docker containers. If you want to run Docker containers in combination with your Windows software, for instance .NET, or if you just want to do some infrastructure is code stuff with ARM, for instance, as I'm going to show in the next session, Docker container support is built into Visual Studio. There is a plugin for Visual Studio 2015. I will of course share my slides with you. Just follow the link and you will get to the download site. And Visual Studio 2017, which came out recently, has Docker support built in it. And for those of you who are running Visual Studio Team Services, or TFS, there are build tasks that you can use for continuous integration and continuous deployment within your CI/CD pipelines. So if you, for instance, build your application on Node, .NET Core, or .NET, you can build the Docker images either for Windows or for Linux directly inside your automated build with VSTS. And release management, so you can, for instance, push your Docker images on the Docker Hub or in your personal registry. So this is the VSTS support. Just follow the hyperlink and you will see more. Now we are coming to an important topic. If we're talking about Windows Server containers, we have a new guy sitting here in the middle, which doesn't exist, as far as I know, on the Linux side. This chart here shows on the left hand side isolation, which is very fast, very lightweight. If you want to run multiple workloads on your servers, you can of course use processes to separate them. You can use containers to separate them. But on the Windows version, you have another option. It's the Hyper-V containers. In fact, you have already seen a Hyper-V container. When I was running the Nano Server on my Windows 10 machine, what Windows 10 has to do, it spins up a separate Hyper-V image, a Hyper-V machine for each container that I'm running. If I'm on Windows Server 2016, I can decide whether I want to run this guy here or this guy here. This one, the Hyper-V container version, it really embeds, it really sandboxes each container in its own Hyper-V image. Why should you do that? Well, it's a question of encapsulation. As you might know, Docker is working because they are sharing the underlying kernel. So you are running a Docker container and your processes run on top of the host's kernel. And with Hyper-V containers, you can embed your containers inside of Hyper-V images, and with that you get much better isolation. You get hardware isolation. You get all the nice things that Hyper-V brings to the table. But to make one thing very clear, the Hyper-V containers do not spin up a fully blown Windows system under the hood to run a host, and inside of this host a container. The Windows version that is acting as the host for the Hyper-V containers is a very optimized Windows, a very small Windows, which is not started from scratch, but this Windows is just copying parts of memory of the already existing kernel, and therefore the host for the Hyper-V container boots up quite quickly, and it can be nearly as fast as the Windows Server containers. Don't get me wrong. I'm not saying that Hyper-V containers offer the same performance as Windows Server containers, but they come close to a certain degree. Another important thing is version compatibility. If you take a look at Microsoft's support policy, if you're running Windows Server containers, so this guy here, which share the kernel, then the guest containers and the host operating system must match from a point of view of the versions. So the Windows version of the guests must be identical to the Windows version of the host. And if you want to upgrade the host or the guests, you have to upgrade both. With Hyper-V containers, that's not the case. With Hyper-V containers, you can mix different versions of Windows and still get support from Microsoft. Well, typically server containers also work if you don't have exactly matching versions, but you don't get support. So let me demo that. Let me demo that one. Let's do that one and spin up a task manager here. And go to the details and go down here. And here you see currently I have two VMWPXs running. These are virtual machine worker processes from Hyper-V. So let me quickly spin up a new command here. Let me make sure that I have switched to Windows. Yes, I have. So if I say docker info, I am connected to my Windows 10 Enterprise machine. And let's do a Docker run interactive with Microsoft Nano Server. Let's do a command prompt. And as I told you, on Windows 10, every Docker container runs as a Hyper-V container. So in a few seconds, maybe you already see it here. Yes, we already see it. We got an additional instance of the VMWP worker process. So we see that under the hoods, a new virtual machine was started, and inside of this virtual machine, my Docker container is running. So if I do the same demo on my Windows Server, which supports Windows Server containers. Let's do that one and go to that machine. To remote desktop. I hope the internet is still up and running. Ah, yeah, here it is. Give it a second to connect. Yes, here we are. Very good. So let me spin up the task manager here too. Something like this. Go to the details. Okay, that's good. And then do a Docker run. This time I'm doing it like this. So Microsoft Nano Server, and do a CMD and do a ping -t. So a ping forever, for instance. This should spin up the Nano Server, and here I am on my Windows Server. And what you see here in Task Manager is now the ping process is running inside a container, but this time I'm using a Windows Server container, not a Hyper-V container. So the ping process is shown in the task manager of the container host of my Windows Server 2016. So I proved that I'm really reusing the existing kernel and I don't get the isolation that Hyper-V offers to me. So you have the choice whether you want or need the level of isolation that Hyper-V gives you. You can decide yourself. Thank you. So I think this one is not relevant here, so let's take a look at that one. I'm very sorry. I need a handkerchief. Please apologize my cold here. Oops. Let's summarize what we have seen about Windows on Windows here. You've seen that you have operating system support for Windows Server 2016 and Windows 10 for the Hyper-V containers. Microsoft has worked closely with Docker to really offer a nice integration with the Docker tools that you install essentially with Docker for Windows. You have seen me switching to Windows container by right-clicking on the Docker symbol in your taskbar, and you can easily switch between Windows and Linux. Just right-click and switch the operating systems. Why should anybody be interested in Windows 10 for containers? Well, for developer purposes. I use it regularly. I use Docker every single day for multiple different occasions. I'm running my Jekyll builds on top of it. I'm running my Node.js compilers, my .NET compilers, all these stuffs on Linux. But still, we are running a lot of software that is based on the .NET 4.5 stack. And I want to have the container features during my development. I want to isolate my ASP.NET Web API 2 applications also inside a container, and I want to run it with the same tools. And this is why Microsoft has integrated Windows 10. In general, what you see is a trend here. Microsoft tries to convince us as developers that Windows 10 is the best operating system for developers, because you have the bash shell on Linux if you want, you have PowerShell, you have the command line, you have containers for Linux and Windows, and therefore you can do a lot of nice things here on Windows 10. Windows Server containers. Yeah, this one is important if you are on the Windows Server 2016 platform, so not on the Windows Client platform, and you want to explicitly run something inside of a Hyper-V container, you can do so by just specifying the isolation switch from the Docker run command. Anyway, again, one thing very clear, Microsoft has not created, together with Docker, a new flavor of the Docker client. What Microsoft did is they contributed to the Go code base of the Docker CLI, so you will run exactly the same code on Windows and on Linux. The Docker client, there is no specific Docker client for Windows. It is the Docker client. Of course, it's compiled for Windows, but it is the same code base. I've shown you that one. I've shown you that one. Ah, yeah. Docker files on Windows. Let me quickly show you a Docker file. I've prepared one here. Let's go here and go to my temp and create a small folder here. Yep. Let's call it DevOps LT17 Live, and go inside and run my Visual Studio Code here. Visual Studio Code has a nice support for Docker files. Create a Docker file, and it doesn't make any sense if you watch me typing, so I'm just copying this Docker file here. This is a Docker file. Of course, if you take a look at it, it's not a Docker file for Linux. It's a Docker file for Windows, because I'm basing my image here on Windows Server Core. I'm using the DISM tool to install IIS. I'm echoing some static text into index.html in the root directory, and at the end I'm specifying an endless ping as the startup command to keep my container running when I start it. Okay, now let's Copy the path, I'll spin up a new command. Let's do a cd here. No, not Docker file. Yes. Yeah, that's good. And again, switch to my Docker host in the cloud. Set Docker host. That one. 2375. Okay, so now we have a Docker file sitting here on my local machine, and let's try to build it. Docker build, let's call it our Stropek DevOps LT 17 live. And yeah, this is the local directory. So now I'm sending the build context just as you're used to from Docker, but this time I'm not sending it to a Linux server, I'm really sending it up into the cloud to a Windows server. So I'm now using Docker on Windows on top of a Windows Server 2016 to build a new container. And now what you see here is the DISM tool that is currently installing inside of this new container that is currently installing IIS. It will take a few moments until we've reached 100%, and then it will take another few moments because I didn't give this virtual machine a lot of power. And as we all know, we have to pay for the cloud, so we have to right scale our resources. And in a few seconds, we should have a ready-made image. So what is the point of this demo here? If you already know Docker, if you already know Docker files, there is really nothing special that you have to think of. Of course, you have to know PowerShell. Of course, you have to know your Windows commands to work with this stuff. But everything else, it's just Docker. You use Docker build, you use Docker images, you use maybe some graphical tools or whatever you want that sit on top of the Docker protocol. It's just Docker. Of course, the content of the Docker file will differ. Very much differ from Linux to Windows, but this works perfectly fine. It will take, I don't know, 30 more seconds or so until it is finished. We will come back to it in a second. Okay, so if you run your Windows on Windows here, you can configure it to a very tight degree by editing a file which is called daemon.json, and I added the link here which goes directly into the Microsoft documentation of this daemon.json file. You can open the ports, you can specify whether it listens on public IP addresses, you can of course do all the certificate fun that you can do with Docker to protect your endpoint. Everything is supported, and please take a look at the documentations. We only have 35 minutes here, so I cannot go into the details of everything. Docker files are supported. Docker files are supported. You can run Windows shell commands, of course, and you can also run PowerShell commands. Please take a look at the Microsoft documentations because not everything is supported in terms of PowerShell. There are a few limitations, and you have to take them into account. Swarm support for Docker on Windows is currently not there. It's coming. There is a private preview for the Windows insiders. You can also already try it if you want, but it's coming on Windows 10, and of course it will come on Windows Server 2016. It's not already there. Yeah, very good. So let's come back to this guy, and here we are. This was what I wanted to show you. Docker images. And here we have our new image, and let's spin it up. Docker run, let's run it detached. Something like this. Okay. Oops. Ah, come on. Yeah, it's here. 9 minutes. Let me quickly kill that one. Docker rm f2b1. I don't need that one. Okay, this is our server. You see it has this endless ping in it, and it's running the our Stropek DevOps LT17 live image. And if I copy my public IP address here and say index.html, if we are lucky and the demo gods are smiling, yeah, I think I messed something up. Let me quickly do that again, because I had another container running and they were competing for the ports. So let's try it again. Okay. Ah, I know what I forgot. Did anybody recognize what I forgot? The port mapping. Of course, you have to do the port mapping just as you have to do it on Linux, because otherwise the port 80 wouldn't be mounted, wouldn't be mapped on the host's port. And now I'm quite confident that it will work. Here it is, hello world Docker file. So I created a Docker file, I built an image, I did some port mapping, and of course volume mapping also works just as you expected here on top of Azure. Docker, let me quickly summarize that, and when we are at the end, Docker is supported, of course, in Azure too. You get lots of support in ARM if you are interested in how to spin up Docker machines, Linux or Windows with Azure Resource Manager automatically. Come to my next session. You have a Docker driver for Docker machine, so if you're using the Docker machine toolset, you can spin up new machines in Azure. You have the Azure Container Service, which is a larger guy. You can run Kubernetes, Docker Swarm, DCOS, and things like that on top of Azure. And finally, there is a Docker volume driver for Azure file storage. If you want to use persistent containers, for instance, then you can do that on Azure file storage. Just follow the hyperlinks in my slide deck if you're interested into more details. I already talked about the tools. So with that, let me come to the summary. Microsoft really loves containers and Microsoft loves Linux. Many people ask me, why? Did Microsoft stop investing in Windows? No, of course not. But you know, if you run something on Azure, it really doesn't matter for Microsoft if you run Windows or if you run Linux, because you will pay for your VMs. And therefore, the whole business model changed. And so they can really embrace the Linux world and the container world. And what they did, as you have seen, you have great support for Linux containers on Windows 10. You have great support for Windows containers on Windows. And you can run, of course, all kind of containers on top of Azure. For me personally, I run development and test purposes mainly on Windows on my machine. You can run your containers on Windows 10 for your development purposes, but if you want to use Windows as your container operating system, you can do so with the Windows Server 2016. And of course, if you want to run larger workloads with swarms or clusters and things like that, you can always go for Azure Container Services and run, for instance, Kubernetes there, and then you have a production scale cluster in the cloud for your Linux-based images. And with that, I would like to say thank you for watching. I hope the demos were interesting, and I hope the slides offer some value, especially with the lots of hyperlinks inside of the slides. I want to say thank you for coming, and I want to open it up for Q&A. If there are any questions from the audience, I would be happy to answer them. Thank you very much. Any questions? Yes, there. Okay. The question, let me repeat the question so that everybody hears it. The question is about licensing. Let me say one thing at the beginning. I'm absolutely not a licensing expert. Absolutely not. I live and breathe in Azure for the last, I don't know, 8 years. And in Azure, you just spin up your machines, and with your Azure costs, you also pay the licensing fees, so everything is done. I'm essentially not worrying about licensing anymore. That's why I don't really care about licensing, but some things I know. There is a specific end-user license agreement for containers, specifically for Windows containers on Windows. You have to read that one. As far as I know, it's just like Hyper-V. So you can run Windows containers on a Windows server that you have licensed appropriately. You can run some licenses of Windows Server on your Windows 10 box just because it's part of Hyper-V. You have to go into the details if you want to run some specific software like SQL Server. If you take a look at the SQL Server instance for Windows, it's just an evaluation license. So it's just for testing and evaluation purposes. And if you want to run production workload, for instance with SQL Server inside of your Windows container, you have to license it separately. So my advice to you is Google for Windows container licensing, and you will definitely find the licensing terms for Windows Server containers. If you run it on Windows Server, as far as I know, and again, I'm not an expert on that, you can just run it just like you can run with Hyper-V. But yes, it is an issue. It's not like Linux that you can run an arbitrary number and you can run production workload inside of a Windows container on your Windows 10 box. That's definitely not the case. So you have to think about licensing if you're not in Azure. I hope that answers this question at least a bit. You're welcome. Any other question? Go on. Exactly the same. Let me quickly show that. I'm here, and if I say Docker run interactive no, I can't show you this demo. It's not prepared properly. But it works essentially the same. It really works the same. You can do the dash V. Of course, I cannot do it here because I'm connected to my Windows server in the cloud and I cannot do a volume mapping across networking. I'm very sorry. So this is why the demo didn't work here. But if you run it locally, it works essentially the same. I'm doing that every single day. For instance, with Windows containers on my development machine. So I'm using Visual Studio to do some programming, and then I want to do some testing inside of a container. So I'm just mounting the Windows directory where my Visual Studio is running on top of, and then I'm spinning up a container mounting the same directory, and then I can do some debugging, or I can do some running some tools inside of the containers and things like that. So it runs exactly the same. Okay. Any other questions? Yeah.
First of all, thank you for your presentation. The Docker containers was new for me.
Okay.
I mean the Windows containers. And I have a question. As we see that Windows are now like integrating Linux support in some mysterious and magic ways. Maybe there are some talks, or maybe even it is now possible to run Linux-based containers on as like Windows containers, you know, with direct kernel support without the Hyper-V VM virtualization.
Okay. Yes, thank you for the question. I get this question very, very frequently, especially now that you have Ubuntu running natively on top of the Windows NT kernel. Some guys think that the Windows NT kernel is now magically compatible with the Linux kernel, and therefore it would be possible to run Docker Linux-based containers without Hyper-V, without a Linux host on top of the Windows NT kernel. To make one thing very clear, that's not possible, and it's not currently not a goal that Microsoft is going forward to. The compatibility of the Windows kernel for the Ubuntu subsystem, for the Bash shell essentially, is to a certain degree, so to a certain degree Windows is compatible with the Linux kernel, but it's not a full 100% compatibility. It would not be possible to run a Linux container directly on top of the Windows kernel. You definitely need a Linux kernel running inside a Hyper-V or VirtualBox image, and inside of that virtual machine you can run your Linux-based containers. So currently, absolutely no way to run a Linux container directly on top of Windows, and as far as I know, this is currently not a goal that the team is trying to achieve, but you know, things might change. I really don't know of any initiative in that direction, because it really works very nice if you run an Alpine Linux inside a Windows Server container. You're welcome. Maybe a last question?
Thank you very much, Rainer. Unfortunately,
The
we
time's
do.
over?
Yeah.
Okay.
Unfortunately, we do not have time for more
Absolutely.
questions, but I guess you would be welcome to answer them right now, just in the hall.
Come to me or come to my next session. I will be here for the whole day. I want to say thank you again for visiting me and yeah, enjoy the rest of the conference. Thank you very much.